Today's lesson is going to be on subtracting mixed numbers with the same denominators. But before we begin this lesson, I would like to go back to subtracting regular numbers with borrowing. And we're going to use some of these concepts and understanding when we are subtracting mixed numbers today. So here we're looking at a problem where you would begin this problem by trying to subtract 2 minus 4. Hopefully you understand that you can't do that, so you'd want to borrow in this case. You would borrow from the tens place. You would take 1 from the existing 2 there, turn that into a 1, and put that 1 in front of the 2 to turn it into 12. Now the question becomes, what is 12 minus 4, which is 8? And my question for you is, how much did you actually borrow from the tens place to give to the ones? We borrowed 1 10. How much is that worth? 1 10 is the same as 1 times 10, which equals 10. So really what you took from the ones place was 10. And you added that 10 to what was already in the ones place, which was 2. So we took 2 and added 10 to it to get 12. That 2 could be any number. We're going to add always 10. We never borrow more than 1 10. So we're always going to be adding 10 to that digit in the ones place. No matter what digit that is, it could be a 3. 3 plus 10 is 13. It could be a 4. 4 plus 10 is 14. You can see that it doesn't matter what digit it is. If you're adding 10 to it, you can simply put a 1 in front of that digit to accomplish the same task as adding 10 to it. Really what you're doing is adding 10 to that digit. Now we look at the tens place. We have over here 1 minus 5, which again, hopefully understand that you cannot do that, so you would have to borrow from its neighbor, the 6, turn that 6 into a 5, and put that 1 in front of the one that's already there. And what we're now turn that 1 into is an 11. But that 11 is not in the ones place, so it's not worth 11. The 11 is in the tens place. So that makes the 11 worth actually 110. So what do we really borrow here? Here we took 1 from the hundreds place. How much is that worth? That is worth 100. And we added it to what was already in the tens place. There was a 1 in the tens place, and 110 is worth 10. So really, we borrowed 100, added it to 10, and we get 110. We don't see the number 110 there. What we see is 11 tens. But 11 tens, or 11 times 10, is equal to 110. So really, we must think about how much we're borrowing as we're borrowing, especially in other areas, like when adding, subtracting units of measurement and having to borrow, or also like subtracting mixed numbers. And that's what we're going to do right now. Here we have 2 mixed numbers that we're trying to subtract. Using the 5 steps I gave you in the last lesson, the first step would be to write them vertically, and I've already done that. The second step would be to check your denominators and make sure they're the same, because just like adding mixed numbers, we can't do anything until we have the same denominators. These denominators are the same already. So our next step is then to subtract the numerators. And when we look at our 2 numerators, we see we have 1 minus 2. And hopefully understand that we cannot do that, so we must resort to borrowing or regrouping. When we regroup, we are really essentially doing the same thing as I showed you in the last slide. We're going to regroup by borrowing from the neighbor to the left, turning that digit, that first digit in the ones place. In this case, we only have 1 digit, and it's in the ones place. So we're going to turn this 5 into a 4. We're going to give the 1 that we borrowed to the fraction in order to increase the numerator, so we can get a bigger numerator than the one below. So how are we going to do that? Well, we have to understand exactly what we're borrowing. We're only borrowing 1 whole. We could simply do what we've done in the past by putting the 1 in front of the 3, the fraction 1/3. However, that doesn't help us. That doesn't solve our problem. We still have a numerator of 1, and we still cannot subtract 2. So that's not what we're going to do. Instead, we're going to realize that what we're borrowing here is 1 whole, so we're going to add it to the fraction that's already there. But we're not going to add it as a whole number. We're going to turn it into a fraction. Now, we can choose any fraction we want, but we're going to add that fraction to the one that already exists. So if we are going to pick any fraction we want, it would be wise to pick a fraction with the same denominator as the one we're starting with. That way we don't have to change them. So we're going to choose 3 over 3. This 3 over 3 is the same as 1. It takes 3 parts to make a whole. You have 3 parts. Same as 1. So when we add these together, we get 4 on top. We're going to add straight across. Add 3 plus 1 is 4. And the 3's stay the same. We can't change the number of parts. And now we have accomplished our goal. We can now subtract our 4 minus 2. We've increased our numerator so that we could subtract. And we'll end up with 2/3. 2/3 is not improper, so it does not need to be changed. 4 minus 2 is 2. Our last step, subtracting our whole numbers. And we have our final answer of 2 2/3. You won't always have to borrow when subtracting mixed numbers. You'll have to look and see by looking at the numerators. Take a look at another problem. Let's take a look at the numerators on this problem and see if you're going to have to regroup. Can you do 2 minus 5? No, you cannot, so you will have to regroup. Step 1, of course, is already done. It's written vertically. Step 2 is to take a look at your denominators. Denominators, same. And then we're moving on to step 3. Step 3, look at your numerators and subtract. Can't be done. So we're going to move to borrowing. And here we have 2 digits that we can borrow from. We have 16. We're still going to borrow from just the first digit. We're going to take 1 from the 6 and turn it into a 5, making this number now 15. And remembering that we're only borrowing 1 whole. So that 1 whole that we borrow, we're going to add it to what exists already as our fraction. And we can choose any number, any fraction that we want that equals 1 whole. So we have to make sure our fraction equals 1 whole, and we're going to add it to 2/6. So what would be a good fraction to use? 6 would be a good denominator because it's the same denominator. We'll be able to add that easily. In order for this fraction to equal 1, the numerator would also have to be 6. Now we can add these two fractions. 6 plus 2 equals 8. And the denominator will stay the same. So now we've accomplished our goal. We now have a numerator of 8. And this fraction is no longer of use to us. And this fraction is really no longer of use to us. This is the fraction we're using now, our new fraction, after having borrowed and added our 1 that we borrowed to our fraction. Now we have 8 minus 5, which equals 3. And the denominator will stay the same at 6. And then our last step, our fourth step I should say, is to subtract our whole numbers, which we have 15 now minus 10, or 5 minus 0, which is 5, and 1 minus 1, which is 0, or just 5. Our last step would be to regroup. I can tell you that we can't regroup this fraction because 3/6 is a proper fraction. However, this is a fraction that could be simplified. We could make this smaller by finding a divisor, a number that we can divide both the top and bottom number by. This is called simplifying. And what is a number that can go both into 3 and 6? That would be 3. So we could divide the top. 3 divided by 3 is 1. 6 divided by 3 on the bottom is 2. This would really be a more efficient answer, a better answer than 3/6. So our final answer would be 5 1/2. If you had 5 and 3/6, technically that is correct, but we want to start looking at all of our fractions and simplifying them or regrouping them if they're improper. Let's take a look. Now I'd like you to try one on your own using your math composition book. Pause the video here, write the problem down, try to solve on your own, then come back and see how well you did. Okay, welcome back. Let's go through the problem together. First step, rewrite the problem vertically. I already have done that. Second step, check your denominators, make sure they are the same. 5 and 5. Continuing on. Third step, subtract your numerators. Check the sign, it is subtraction. Subtract your numerators. 1 minus 2. Realizing that you can't do that, we're going to have to now borrow. So we're going to take 1 from the 4, turn that 4 into a 3. We're going to borrow 1 whole. So we're going to add that 1 whole to the existing fraction. We're going to create a fraction that equals 1. The denominator should be the same. That makes it easy. And the numerator then would have to be the same as the denominator. And now we can add 1/5 plus 5/5, which equals a total of 6/5. We've now accomplished the goal of creating a larger numerator. And these fractions are not really needed anymore. We're now looking at 6/5 minus 2/5. 6 minus 2 is 4. The 5 stays the same. We never change how many that takes to make a whole. And our final step, or our fourth step, is to subtract the whole numbers, 3 minus 2, which equals 1. The final step, of course, would be to look at our fraction. We want to look at this fraction and ask ourselves really 2 questions. One is it improper? Which likely it is not. When we're subtracting fractions, it's not likely to be improper. And the second question, the more likely question when subtracting, is can we simplify it? Is there a way to reduce both the numerator and denominator? Is there any number, any divisor you could think of that would go into 4 as well as 5? And there really isn't any. If you're thinking of the number 1, you could use the number 1. However, you would end up with the same exact thing. So we're looking for numbers greater than 1 in order to simplify. Here's your next problem. Pause the video, work it out, come back and see if you got it correct. Welcome back. Step 1, already done for you, written vertically. Step 2, checking your denominators. They are the same. Step 3, subtracting your numerators. First checking to see that you can. 2 minus 4 cannot be done. Hopefully you borrowed. And you borrowed from a double-digit number over here, 12. Really, we're only going to take one number from the 2 and turn that into a 1. So our 12 is now going to be 11. We're taking 1 whole from that 12, turning it into 11. We're going to add that 1 whole as a fraction to our existing fraction to make that numerator larger. And we know it has to equal 1 whole, and it has to have the same denominator when we add, so we're just going to create one that has the same denominator. Make it 7 over 7. Then we're going to add 7 plus 2 to get 9, and the 7, of course, will remain the same. Now, we do not need these fractions anymore, and we are working with this fraction and subtracting 4/7. We've accomplished our goal of increasing our numerator, and we can subtract 9 minus 4. That will give us 5. The denominator will stay the same. And over here we have our whole numbers. Our step 4 is subtract whole numbers, 11 minus 8, which gets us 3. Our last step is to check to see if we could regroup or simplify. Well, we can't regroup because this is not improper, so we look to see if we could simplify. Is there a divisor we could divide both top and bottom number by? And there really isn't one, except for 1, and we've already discussed that's not going to be a very good choice. So our final answer is 3 and 5/7. Great job. If you happen to miss this one or the one before, go back and write those down again and try them one more time. It's okay that you've seen the solutions. Trying them on your own will help you practice the solutions. It's going to help you build those neural pathways and make those connections between your neurons. The more you practice it, the better you'll get. We're going to be taking a look at mixed numbers with like denominators again. We're going to be using the exact same steps that we used in the previous lesson. The first step is always to rewrite the problem vertically, standing on top of each other. I'm just going to do that from now on. The second step is to take a look at your denominators and make sure that they are the same. If the denominators are not the same, we'll have to change them. Today we'll keep them the same. The third step is then to subtract our numerators, remembering that our denominators stay the same. We're going to be subtracting the numerators. So when we look at our two numerators, what we find is that we have a situation here, a problem. We have 1 minus 2, which cannot be done. So we're going to have to learn how to borrow or regroup to solve this problem. And it is not going to be done exactly like it is done with regular integers, regular numbers. In this situation, like I was showing you earlier, we want to realize that we really only have one thing to borrow from. We need to increase the amount of our numerator in order to subtract 2. So to do that, we need to borrow, and the only thing left in this number to borrow from is the 5, and that 5 is worth how much? It's only worth 5 because it's a 5 and it's in the ones place. So it's only worth 5 units. We're going to reduce that 5 units the same way we would normally do that, by taking 1 away from it, turning that 5 now into a 4. However, when we give that unit to our fraction 1/3, we can't simply do it the way we've done in the past by putting a 1 in front of it. We have to realize exactly how much we're borrowing. We're only borrowing 1. So what we need to do is to add that 1 to the fraction that already exists. Now we could add a whole number 1 to that fraction, but that's not going to help us, because if we did that, then we would end up with 1 and 1/3. This does not increase our numerator, and it doesn't allow us to subtract 2 from the numerator 1. So instead, what we're going to do is we're going to add that 1 as a fraction so that we can continue to keep our fraction and thereby increase our numerator. So we're going to add it as a fraction. Now we can add any fraction to 1/3 that we want as long as it equals 1. And we know that a fraction that equals 1 has the same denominator as a numerator. So we're going to be smart about this and always pick the same denominator that we started with. So if we keep the same denominator, 3, then the numerator, in order for this fraction to equal 1, would have to be 3 also. And now we can add these two fractions together, and we will get 4/3. Now you can see that we have an improper fraction, but that is okay. We purposely created an improper fraction. Our goal was to increase the numerator, make it large enough to subtract 2 from it, and we have done that. And how we have done that is very similar to what we do with regular integers.